Okay, let's work through this. Task was make a table for the toolkit exponential function, then table for the toolkit logarithmic function, and graph the toolkit logarithmic function. Okay, well, table, toolkit exponential function. Nobody got the table right. Everybody got the -2 through 2. Where's that come from? Well, let's just review your toolkit exponential function. That you can construct the graph. So I'm not going to explain the construction because you should have done this construction many times. Find out. We get a point here, a point here, point here, a point here, and a point here. And you sketch the curve, and you know that these points are -2, 1/4, -1, 1/2, etc. I guess 2, 0, 1. Okay. Now there are rules of algebra, and rules of algebra have to agree with what happens over here. Okay, and the rules of algebra tell us that 2 to the -2 is 1/2 squared, which is 1/4. That's a rule for algebra. Okay. A negative exponent, if you raise a number to negative exponent, it's like 1/, that number to the positive version of that. Okay. I can write that out more specifically. If this should be 2 to the -1 is 1/2 to the 1, which is 1/2. And notice that -2, 1/4, -2, 1/4. What we get from the rule for exponents agrees with what we got when we construct this graph. Okay, and 2 to the 0 is 1. 2 to the 1 is just 2, and 2 to the second power is 4. Now, on the test, you have to write this stuff out. Okay, because you're going to have a calculator, and I don't want these things being calculated. Obviously, if you want to calculate 2 to the 1/2, you're going to need a calculator. Here's how you make a good estimate for the graph. Sometimes the graph could be sufficient. But it's fine to use a calculator when you don't have easy numbers. But right here, you got these easy numbers. Okay, now then the next thing is, okay, how do you do the graph of log base 2? Inverse to the x function. How do you do table of the inverse? We switch x and y. If we're doing it algebraically, we take the algebraic function and we switch x and y. So the x column here is -2 through 2. The y column is going to be -2 through 2. The x column or the y column has 1/4, 1/2, 1, 2, and 4. So now we can sketch the graph. Our x numbers have to go from 0 to 4. Of course, it goes from 1/4 to 4, but we're going to want the interval from 0 to 4, which is here. I'm going to go ahead and cut that interval in half. You know that here's for x equals 2. Cut this in half. Here's for x equals 1. Cut this in half. Get x equals 1/2 here. And cut this one in half. X equals 1/4. So conveniently, these are just the numbers that are on our table. So we just keep cutting in half. And we get everything we need in order to sketch this graph. Okay, now y goes from -2 to 2. So I might as well put y equals -2 up here. Y equals 2 up here. And then we plot our points. 1/4, -2, that'll be down here. And you know, how's that related to 2, -2, 1/4? We've switched the x and the y. Okay. The y value here is 1/4, that becomes our x value. The x value here is -2, that becomes our y value. Well, then we can do y equals -1. Y equals 1. So we can plot the rest of our points. Okay. The point -1, 1/2 reflects or transforms actually as a reflection of it. I'll flip. And then I would have the point 1/2, -1. And then the point 0, 1, 0, the point 2, 1, and the point 4, 2. And right here's our point. So take a minute, sketch that graph, then we're going to do some transformations. And you know, it's worth noting that one person sketched the graph of the exponential function as well. And of course, that graph has the characteristic that if we take the line with y equals x, 45 degrees, the graph of the exponential function will flip such a way that every point up here corresponds to the point down here. And if you draw a straight line from this point to the corresponding point, like if this is 2, 4, this is 4, 2. If you use the equal scale for x and y, equal scales for x and y, then this line here will be at a right angle with your y equals x line. And that's an important characteristic, so I'm glad somebody chose to show that. Okay, so these 5 points are the 5 points that we construct when we construct our toolkit graph. And these 5 points are reflections of those points about y equals x line, which simply means that we switch the x and the y coordinates. We reverse the x becomes y and the y becomes x. Okay, that's very important. So I'm glad I saw that. Now, let's try the graph of y equals log base 2 of x minus 1. Now, another thing you might notice if we look at the way I sketch these lines, the divisions I made on the x, I go halfway to the bottom edge, then halfway again, halfway again, halfway again. It's like the bottom edge of our rectangle is now the left edge. So we go 4 by 4 rectangle. We start out here at x equals 4, go halfway to the left edge, and halfway again, halfway again, halfway again. So this rectangle with the construction lines I've drawn here is exactly the same as this one. Okay. If I rotate the thing back this way and then flip it over. Now, you don't have to actually do that, but what you see is my vertical rule for the construction line becomes a rule for horizontal rule for construction lines. That is, my rule for horizontal construction lines becomes my rule for vertical construction lines. And my rule for vertical construction lines, where I go middle and then halfway to the middle and halfway to the middle. Right there it is, same lines. Okay, so we can quickly construct a table for log base 2 of x. So I'm going to just say, okay, I've got a pulled up whole rectangle here. And I'm going to subdivide it here, and here, and here. And then I'm going to divide it here, and here, and here, and here, and here's all my points. Now here is x equals 4. Here's my y-axis. Here's my x-axis. Here's the line y equals 2. Here's the line y equals -2. Here's the line where x equals 0, and so forth. Okay. Now, if I want to do the graph of y equals log 2 x minus 1, well, here's the graph of y equals log 2 x. However, we get the graph. There it is. And what's going to happen if I do log 2 of x minus 1? That means every y value is going to be 1 less, which means that every point. Okay. I don't know why I want to use the chalk, but I got my line. That's what I'm going to do. Okay. So this point is the point 4, 2. If I do log base 2 of x minus 1, then the y value is going to be 1 less. Y value here is 2, so the y value is going to become 1. So this is going to be the point 4, 1. And if I look at my table, I do log base 2 of x minus 1 when x is 4, y is 2, so log base 2 of x is 2, so log base 2 of x minus 1 is going to be 1. Does that make sense? And that's my point. Just leave myself room to label these points. But what are the coordinates of this point? This is a point 2, 1. Becomes 2, 0. Okay. I guess I could label 2, 1 here. Didn't plan that very well. The point 2, 1 here goes 1 lower to 2, 0. Every point goes 1 unit lower between the minus 1. Just draw little arrows. Like 1. And now I've got my points on the new graph, and I can connect them. Like so. So the white graph is log base 2 of x. Blue graph is y equals log base 2 of x minus 1. Now, however you choose to construct it, do a graph of log base 2 of x, and then see if you can sketch the graph of y equals log base 2 of x minus 3. So with a little practice, we understand where the points are on the graph base 2 log. So we should be able to quickly kind of line off y equals 2, y equals -2, x equals 4, and see where the points would lie. It might be helpful to have these vertical lines. You need them. Use right here is the graph. Yeah. Of y equals log 2 of x. If y is log 2 of x minus 3, then you're going to take whatever the y value is for log 2 of x, then you're going to lower 3 units. So every point goes 3 units lower. This arrow represents -3. Represents going 3 units lower. And now we get points on this. And that's just your basic transformations. Okay. Now, if you want y equals 2 log of x, what do you do then? Again, we can start the graph, knowing what's going to happen. Leave myself up above. Slide should have been somewhat lower. That angle of the board, I'm being careless. But here we have our bounding lines, y equals -2, 2, x equals 4. Here x equals 0, which is the y-axis. And we, again, locate our points. I'm going to draw the construction lines to the top. But in my log base 2 of x graph, and now I have to double on my y values. So, work on that. If you're trying to do the graph of y equals 2 log base 2 of x, you can start with a graph of y equals log base 2 of x. We're doubling the y value. The y value of 2 log base 2 of x is twice as great as the y value of y equals log base 2 of x. So, this point, here's an xi, turns out to be 4, y is 2. If we double 2, we get 4. So the graph here contain a point that's got twice the y value. Here, the y value is 1. If we double the y value, we get 2. Same x value. No, x is 2 here. Log base 2 of 2 is 1. If we double that, we get 2. This point, x value is 0. If you double zero, you get zero, the y value is still zero. Now my scale's a little off here, but if x is -1 here, I'm sorry, y is -1 here, and this occurs when x equals 1/2, and we double -1, we get -2. We double -2, we get -4. So the graph ends up looking like this. Now I've got a little more labeling up here. It's the same picture. I say that 4, 2 is on the graph of y equals log base 2 of x. So 4, 4, because your y value has to double. Your y value is 2 here. Your y value goes to 4 when x equals 4. When you double the value of log base 2 of x, and we get the point up here, which is 4, 4. This point would be 2, 1. If we double the y value, we get 2, 2. Here y is 0. If we double that, we get 0. So we have the point 1, 0. This is a point -1, -1. I'm sorry, negative. This is a point -1. I'm going to say it right here. This is a point 1/2, -1. If we double the y value, we get -2. So 1/2, -2. I'm going to have 1. When x is 1/4, y is -2. And if we double that, we get -4. So we're going to be down here. There's another picture with a little more detail on how we get these sums. No, it's just transformation. Okay. It's a vertical stretch. We just vertically stretch this graph by factor 2. I'll make the statement y equals 2 log base 2 of x. Vertical stretch by factor 2. Y equals log base 2 of x. Now we have to move on and begin talking about something else. And we'll rely on open math to fill in a few more details, like what happens if you want to do y equals 2 log base 2 of x minus 3. Well, all your y values are going to be same as the 2 log base 2 of x values, but 3 units less. So the point here for y equals 4, 0.44, will go down 3 units to the 0.41. This point will go down 3 units, end up down here. This point will go down 3 units, and so forth. Now we really need to understand this. This is something we've been dealing with through the whole course, and this is the last time we're going to be dealing with transformations for exponential and logarithmic functions. So we need to get it down now. It will be substantial on the exam. Okay. Be a substantial part of the exam. Not, for any function. Give you just any old graph of f of x, you should be able to sketch the graph of 2f of x minus 3. Now I want to talk about modeling. The name of the section is modeling with logarithmic functions, but I'm just going to talk about modeling. I'm going to start just with a general idea, an exponential function. has value 3 when x equals 2, and value 5 when x equals 6. Now, what's the form of an exponential function? F y equals a times b to the x. I'll use the capital A. Or y equals a. Got to switch myself out of log one here. Y equals a times 2 to the kx. Y equals a times e to the kx. These are 3 valid forms of the exponential function. If we use the form y equals a b to the x, you can do this for any of the forms. I'm going to start with the a b to the x form. If y equals 3 when x equals 2, and 3 equals a times b to the second power. If y equals 5 when x equals 6, then what can you write? So that gives you 5 equals a b to the 6, because we're replacing x and y with the values that go together. Gives us a system of equations. 3 equals a b squared. 5 equals a b to the 6th. There are 2 numbers we don't know, a and b. There are 2 equations. Well, as we did with linear equations, if we know 2 points on a graph of a linear equation, we can plug those points into a form y equals mx plus b, get 2 simultaneous equations and solve them for m and b. Here, we're going to be able to find 2 numbers that tell us what a and b are. So here's equation 1. Here's equation 2. Quickly solve equation 1 for a. What do you get? Okay, well, equation 1 tells you that a is 3 over b squared. Plug this result into equation two. What do we get? We get 5 equals A, which is now 3 over B squared, multiplied by B to the 6th. Simplify, and we're going to switch sides. Well, B to the 6th divided by B squared is B to the 4th. So we get 3B to the 4th equals 5. And we solve for B. Use the board space I have here. Okay. We come over here, I'm going to write it out again. 3B to the 4th equals 5. We divide both sides by 3, we get B to the 4th equals 5/3. And how do we solve B to the 4th equals 5/3? Well, of course, we have to understand the laws of exponents. B to the 4th is then 5/3 to the 1/4 power. Or if you want to write it, you do the 4th root. I like to use powers because we can apply the rules of exponents, which you need to review if you don't know. Okay. And also refer you to place it on intermediate algebra class where we went over it if you need. That's an email if you do. So that B raised to the 4 times 1/4 5/3 to the 1/4. So B is 5/3 to the 1/4. And 5/3 to the 1/4 is pretty close to 1.3, about 1.13 or 1.14. Might be 1.14. Wait a minute. Yeah, I think it's probably close to 1.14. Okay. So what you got B. Okay. So we got B approximately equal 1.13. So that A equals I keep thinking it's probably close to 1.1. Well, I'll stick with 1.1. But I think maybe 1.14 is close. Anyhow, A is 3 over B squared, which is 3 over 1.13 squared. So that should be approximately equal to 3 over 1.3 would be 2. Approximately 2.4. And I always done in my head, so square to it. So y equals ab to the x becomes y is about 2.4 times 1.13 to the x. Now, I don't have time to fully explain the algebra. This is algebra 1, maybe a little bit of algebra 2. But we need to understand the rules for exponents. So I'll just give a quick explanation again. The overview of what we did and then a little bit about the details. Okay. Any one of these could be the form of an exponential function. We could pick any one. We could pick this one. And we plug our x and y values in. Each set of x, y values gives us an equation. So we get this equation, we get this equation. This equation, these two equations and two unknowns, we can solve to get the values of a and b. Okay. We start by solving the first equation for a. Divide both sides by b squared, we get 3 over b squared. And plug this value in, or this expression into equation 2. Well, where you have a in equation 2, you're going to have 3 over b squared. So you're going to have a 5. You're going to have a, but that's replaced by 3 over b squared. You've got b to the 6th. Okay, well, we simplify this. If you divide b to the 6th by b squared, you get b to the 4th. So you get 3b to the 4th, and that's going to be equal to 5. Well, then we solve for b. We divide both sides by 3, we get b to the 4th equals 5/3. And then we use the rule of exponents. B to the 4th to the 1/4 would have to equal 5/3 to the 1/4. Now, why do we do b to the 4th to the 1/4? Because if you raise a power to a power, you multiply the powers. B to the 4th to the 1/4 is then b to the 4 times 1/4, which is just b to the 1 or b. So b is something like 1.13, if my mental calculations are correct. Now, once we have the value of b, we know that a is 3 over b squared. So we write a equals 3 over b squared and replace b by our 1.13. I'm guessing like 1.136 or something like that. That's too good to guess. Okay, so 3 over 1.13 squared is, I'm thinking around 2.4, maybe 2.5. Okay, probably 2.4. Actually, I won't say that. Might well be 2.5. Okay, anyhow, then our assumption y equals ab to the x becomes this. Now, I'll kind of repeat just the logic of it. Too far ahead, we're not thinking. That's rough. The numbers might be just a little different than what I got there. But that's a model. Now, that model. Oh, if you give the values of A and B, we can say, okay, I've got a graph. Y versus X. And the graph has to go through the point 2, 3. Here, X equals 2. Y equals 3. And 5, 6. So when x equals 5, y equals 6. I have these 2 points on a graph of an exponential function. If I try to sketch a graph of this thing, graph might look like this. Not very well done. There's only one exponential function that goes through these 2 points. That exponential function could be expressed in the form y equals ab to the x. And we use that form because that's the one we chose, but could also be in this form or this form, or actually in a number of other possible. Any of those forms will give us the exponential function, and every one of those forms is equivalent to every other. Again, in this case, y is about 2.4, excuse me, times 1.13 raised to the x. How could we apply this? Let's say we have a bacteria culture. Bacteria culture, it's a little difficult to find out how many milligrams of bacteria you actually have. Okay. You often just look at the area of a bacterial film in a petri dish. And I'm no biologist, so my knowledge of biology is pretty much what I gained. I have got the opportunity to take a biology course. The school I went to was just mathematical sciences and engineering. Okay, so anyhow, in bacteria culture, though, we have 3 milligrams of bacteria after days. And 6 milligrams after 5 days. Okay. We can take that information and put it on a graph. So we have 2 points on a graph. If we have 2 points on a graph in the form of the function y equals ab to the x, we can plug the x and y values of this point in here, and we get an equation. We plug the x and y values of this point into this, and we get another equation that we can solve for a and b. Using y equals a b to the x form, we get equations, repeating again, 3 equals a b squared, 5 equals a b to the 6. Solutions A equals something like 2.4. B equals something like 1.13. Function is this. So we can say y equals m of x equals 2.4 multiplied by 1.13 to the x. Model the growth of the culture. Now, two questions we can ask. When is y equal to 4? What will y be when x is 2 days? Now we go back to something we did near the beginning. And we say, okay, y equals 4, but here's y equals 3, and here's y equals 6. So here's y equals 4. And we can estimate that if x is 2 here and 5 here, well, x would then equal 2.5 here. Somebody saying x would be 3.5 here. That looks like x equals about 3. I remember at the beginning of the semester, we sketched graphs. We said, okay, what's x if y equals this? What's y if x equals this? And everybody did pretty well with that. So we need to resurrect those skills and see what this says on the graph. And this kind of tells us, I'm going to change this question to when x equals 4 days. Because it looks like 3 is about our estimate for when y equals 4. And I don't know how that negative sign got in there, but it did. To answer these questions, all of y equals 4, that was 2.4 times 1.13 to the x equals 4. How do we solve this equation? Well, say then look at 1.13 to the x is going to equal 4 over 2.4. So that x equals log base 1.13 of 4 over 2.4. Just using standard way of solving an exponential equation. And well, you can solve that, see how close it comes out. X equals 3. If x equals 4, y equals 2.4 times 1.13 to the 4th. Okay. 2.4 times 1.13 to the 4th, something you can easily enter into your calculator. Log base 1.13 of 4 over 2.4. Well, that's log of 4 over 2.4 divided by log of 1.13. In other words, this is something you know how to solve. And this is even easier. You can just plug it into your calculator directly. Okay? And a calculator is totally appropriate. 1.13 to the fourth. You know, I thought that that was going to be around 5/3, 1.66. Okay? Now I'm debating between 1.13 and 1.14, but I think it's one of the two. Rounded to two significant figures. Three significant figures. Okay. We'll talk more about this on Thursday.